All right, let's talk about algebra. I know. For a lot of people, it feels like this huge, scary thing. But what if I told you it's not a monster? It's actually just the puzzle, a logic game with a really clear set of rules. And here's the best part. There's always an answer. So we're going to give you the roadmap to solve that puzzle every single time.
You look at something like this, right? And your brain just kind of freezes for a second. You've got parentheses, variables on both sides of the equal sign. I mean, where do you even start? It looks like a total mess. But trust me, stick with me for a bit because we're going to build a step-by-step guide that makes a problem like this feel completely doable.
So, first things first, before we can solve any puzzle, we have to understand the language it's written in. So before we try to tackle that beast of an equation, we've got to go back to basics and decode the fundamental rules that run the whole show.
Okay, this right here boils it all down. At its core, an equation is just a perfectly balanced scale. That equal sign smack in the middle, it's the whole point. It means the left side and the right side have the exact same value. Our one and only goal is to figure out what x is, to get it all by itself on one side. And our main tool for doing that, something called inverse operations.
Think of inverse operations like the undo button on your computer. You know, Control-Z. They're just opposites that perfectly cancel each other out. If you see addition, you use subtraction to get rid of it. If you see multiplication, you use division. This simple idea is the key that unlocks pretty much every equation you'll ever face.
So we have our undo buttons, but how do we actually use them? Well, it all comes down to the most important rule in all of algebra, the art of keeping things in balance. We'll start simple, and then we'll add just one more layer.
And here it is. This is it. The golden rule. The one thing you can never, ever forget. Think about that balanced scale again. If you add a 5-pound weight to one side, what happens? It tips, right? To make it level again, you have to add the exact same 5-pound weight to the other side. It is that simple, and it is absolutely non-negotiable.
Okay, let's see this whole thing in action. Our goal is to get x all by itself. So we have to work backwards, kind of like unwrapping a gift. The last thing that happened to x here was adding 6, so that's the first thing we undo. We subtract 6, but we have to do it to both sides to keep it balanced. Now, all we have is multiplication. So we undo that by dividing both sides by -2. And just like that, the puzzle is solved. We know for a fact that x equals -2.
All right, so one-step and two-step problems, we got them. But what about that monster from the beginning? For something like that, you need more than just the rules. You need a GPS, something that gives you turn-by-turn directions no matter how crazy the problem looks. And this is it. This is our GPS. I know it might look a little complicated, but it's actually the opposite. It's designed to make complicated things simple. This flowchart takes all the guesswork out of it. You just start at the top and follow the path. It tells you the exact next step to take every single time. All right, let's take our new GPS for a spin. We're going to use this problem from our source material. It's perfect because it's got parentheses, it's got multiple x terms, it's exactly the kind of thing this roadmap was built for.
Okay, let's follow the map. First question, are there parentheses? Yes, so our GPS says use the distributive property. Boom, that gives us 3x minus 15. Next question, can we combine any like terms? Yep, we've got a 3x and a 2x on the same side, so we can put those together to get 5x. And look at that, we just turned a messy, confusing problem into a simple two-step equation that we already know how to solve. Add 15 to both sides, divide by 5, and there it is. The roadmap led us right to the answer. X equals 12.
Now, let's talk about a special type of problem that comes with a really cool shortcut. Sometimes equations will look like one fraction set equal to another one. And when you see this, there's an awesome trick you can use. This setup is called a proportion. It's just a fancy word that means two ratios are equal. It's like a recipe. If one batch of cookies needs 2 cups of sugar, then 2 batches need 4 cups. The ratio is the same. Here, the ratio a/9 is the exact same as 7/6. And here is that amazing shortcut. It's called cross multiplication. You literally multiply in a diagonal line like a big X right across the equal sign. So the a multiplies by the 6 and the 9 multiplies by the 7. And just like that, the fractions are totally gone. You're left with a super simple one-step equation. 6a equals 63. I mean, how easy is that? So far, every single problem has been about finding that one single number that makes the equation true. But what if the answer isn't just one number? What if it's a whole bunch of numbers? Well, that's when we get into inequalities.
So instead of that trusty old equals sign, inequalities use these symbols here. But here's the cool part. You solve them using the exact same tools we just learned. Inverse operations, keeping it balanced, the whole thing. It is 99% the same process, with one tiny but absolutely critical little twist.
And this is it. This is the one special rule you have to burn into your brain. If and only if you multiply or divide both sides of an inequality by a negative number, you have to flip the sign around. A less than becomes a greater than or equal to becomes a less than or equal to. That's it. That is the only new rule.
The side-by-side comparison makes it crystal clear. Over on the left, with the equation, we divide by -3 and we get our single answer, x is 7, period. On the right, we do the exact same math, but, and here's the key, because we divided by a negative number, we have to flip that sign. And all of a sudden, the answer isn't just 7, it's that x can be 7 or 8 or 100 or any number that's bigger than or equal to 7. That one little flip changes the entire meaning of the answer.
And this is how we draw a picture of all those possible answers. See that circle on the number 6? Because it's an open circle, not filled in, it means that 6 itself is not a solution. It's like the starting line, but you can't actually stand on it. Then, that arrow pointing to the left shows you every single number that is a possible answer.
So now you have the roadmap. You have the golden rule for equations, and you have the one special twist for inequalities. So my question to you is, if you look back at all the problems from our source sheet, which one of them gives you this exact picture as its answer? The tools are all yours. It's time to solve the puzzle.